Hi. In this video, we're going to be working on Inferential Data Analysis Lab, and we're going to be using two different applets that are available for free on the web. I'm going to share my screen, show you where the lab is posted on Blackboard. So, coming over to Data Analysis Assignments, and let's go look at in the folder Inferential Data Analysis Lab. Open up I'm going to work with the Word document. I'm going to type my answers right into the Word document, so maybe you can do the same thing and then save it. Okay, so just states the two websites that we're going to use. The first one we've used before in the first data analysis lab that we did. So let's go ahead and look at the problem. The mean wait time at a drive-through of a fast food restaurant from the time the order is placed to the time the order is received is 84.3 seconds. A manager devises a new drive-through system that he believes will decrease the wait time. To test the claim, he initiates the new system at his restaurant and measures the wait time for 10 randomly selected orders. Here are the wait times. So we're going to answer these four questions. And for each of the questions, we need to give a screenshot of the output that we got from the applets, as well as we need to answer the question itself. Okay, so we'll go on over here, and for number one, we're asked to use this website. This is the one we've used before in the beginning of the semester, to calculate the mean, the standard deviation, and the 5-number summary for wait times. So bringing that up. Okay, so I hope that you remember this a little bit. But if not, we enter data on the left column. We ask for what we want on the right column, and the answers come in the middle. So the first thing we have to do is remove the sample data. Okay, and then we'll go back to our problem statement. And I'm going to copy this data all the way from the first quote of wait times down to 72.0. And I'm going to paste it right here in this box at the CPM website. Okay, and I'm going to look. We have just checked that you get the quote, wait time quote, and then all of the 10 data points. And we can look here, and by default, we see a graph, but our first problem is actually around summary statistics. So we'll come back to the graphs, and we'll go right now to the summary statistics. So click on the box on the right that says show summary stats. And we get this box. And this box has the mean, the standard deviation, and these last 5 are the 5-number summary, the minimum, Q1, Q2, also known as median, Q3, and then the max. So let's go ahead and grab this. So I'm going to use print screen and paste this over in the Word document. So if you have questions about how to print the screen, how to do that, that screen capture that I just did on how to take screenshots. Okay, so it's in the data analysis assignment content area. So clicking there. So just to remind you if you need that. Okay, so let's go back to our Word document. And remember, the questions we're asked for is the mean, the standard deviation, and the 5-number summary. So I'm going to go ahead and answer the question by typing in the mean is, and then coming on over here and see it's 78 seconds. The standard deviation is, and we see here standard deviation. I am choosing the sample standard deviation rather than the population standard deviation because the problem stated that this was a sample. So the standard deviation I need is the sample standard deviation, which is labeled here as standard deviation. Okay, and the 5-number summary is equal to, and we'll go ahead and just list this without parentheses and commas, which is the standard presentation mode for this summary. Okay, so the minimum is 58. Q1 is 67.4. Q2 is 73.95. Q3 is 86.3. And the maximum is 108.5. Okay, so that's what we need for the first problem. We have a screenshot of our output from the applet and then the direct response to the questions that were asked. Okay, so the next problem says use graphical techniques here at this same screen, at the same CPM univariate to visually display the data and identify any outliers. So coming on over here, we have a choice of graphs. We could use a box plot, a histogram. I'm going to go to the box plot, but you can work with the histogram if you want. Remember, if you're working with the histogram, you might want to play around with the bin width here. I'm going to show you, oops. So that's one possibility. I changed the bin width to 10 and you can see the data a little more, a little better summarized. But for right now, just for the simplicity of it, I'm going to go to box plot. And in the box plot, we see, here's the box plot. And notice that there are no stars, right? And so in a box plot, if there's outliers that are identified as stars. So we're going to take this as our graphical technique, as our graphics, and we'll take a screenshot of it. And let's paste that over in our on our Word file. So for problem 2, we have the output from the applet and a direct answer there to the question are no outliers. Okay. Good. So moving on to problem number 3, it says use the application linked below to produce the 99% confidence interval and interpret the interval in the context of the application. So I'm going to go ahead and grab the link. This link is going to bring us over to this other, a different and very useful set of tools here. So this opens up right to the confidence interval calculator. And but if you wanted to play around and just explore, you could click here on calculators and you could see that you have different calculators. This is the T statistic calculator. So confidence interval, the T interval calculator, but there's all these other ones as well. Okay, so I'm just going to go back and work on our problem. So in this problem, in this app, we're asked to, I know lots of ads, sort of distracting. Okay, we're asked to put the summary stats right here, and we got this in the previous problem.
With a great deal.
Okay, just stopping to stop sharing the screen while I quiet down the ads from the.
On the Hyundai you've always wanted.
So hold on
If
one
your
moment.
journey, own every mile at the Hyundai Getaway Sales Event. Hurry.
Okay, so I'm going to share my screen again. Hopefully the ads are rather quiet, but you never know. It's what you get for free. Very useful, but kind of has that limitation. Somebody has to pay for it, I suppose, and I don't want it to be me. Okay, so the sample mean we got from problem 1, it was 78. The sample size was 10. There were 10 observations. The sample standard deviation, 15.205. And the confidence level that we have been asked to find was at the 99% confidence interval. So we're going to click the calculate button. And down here we have our results. So taking a screenshot of the results. Okay. And we'll bring over our lab report that we're working on. And let's go ahead and, oops, that's the wrong one. Okay, and so problem number 3, I'll start this down here, just to give me a little space. So first I'm going to paste the results and then I'm going to answer the question. The question says, what is the 99, produce the 99% confidence interval and interpret it. So the 99% interval is, and it's over here, 62, it's right, given in both of those locations, 62.37. The upper bound is 93.63. The interpretation, we are 99% confident that the population mean wait time is between 62.37 and 93.63 seconds. Okay, so that's problem 3. Let's look at problem 4. Problem 4 says, use the application linked below to answer the question. At the 1% significance level, do the data provide sufficient evidence to conclude that the mean population time of the distribution of all wait times using the manager's new drive-through system is less than 84.3? So I grabbed the less than because we know that's the key word. We're asked to do the use the application to calculate the p-value, and we're going to present the solution using our 6-step hypothesis testing procedure. Okay, so before we even go to the website, we're going to start with the null and the alternative hypothesis. Step 1, step 2 is going to be the statement of alpha, the significance level. Then when you do this, you don't have to use fancy math type. I'm just going to go ahead and not do that. So H naught, and just type it out like that. Mu, I mean, if you like to use the math type, you can, but you don't have to here. Mu is equal to 84.3. And then the alternative is going to be mu is less than 84.3. So H1. Mu is less than, we had that keyword. Okay. So my second step in the hypothesis testing is a explicit statement of alpha. And in this case, we're given alpha is at 1%. Significance level is at 1%. So there we go. There's our alpha. Okay, so we know, let's get it up. Let's get it here that this is going to be, we're going to do a t-test here because we don't know the population standard deviation, but we can do the t-test because we have the data, and the data will yield all the things we need, like sample standard deviation, which we already reported in part 1. So sample mean as well. Okay, but so here we want to calculate a t statistic, and then in step 4, we're going to find the p-value. And then in step 5, we're going to compare the p-value to the alpha value and then make a decision to either reject the null hypothesis or do not reject the null hypothesis. That's step 5. So let's go ahead. I'm just going to set it up, right? Because this is how I usually do it. So we'll get the p-value, we'll pop it in there, and we will compare it to alpha. which we know is 0.01. All right, so we have to go off to the website now. Let's go ahead and grab the address. So this is the t-test calculator. And take me to the calculator. Okay. So here we're going to put in the null mean, which here it was 84.3. And then over here, it asks for us to put in all of the sample data. So we have to go back to the Word document and copy that sample data again. This time we don't really need the header wait time. We just need the 10 numbers. So highlight and copy that, and we'll paste it right in here. Okay, we're asked that we have to give the significance level. So we're going to put the significance level in there. We are doing a one-tailed test because we're interested in less than, right? That was the question. Has the new system decreased the wait time? All right, so one-tailed test, and we'll calculate. So down here, we have all the things we need. Let's go ahead and copy this. It's t-value, there's a p-value, and there's a word that it is not significant, which means we do not reject the null hypothesis. So let's go ahead, put this down here in our lab report. I'm going to pop it right in here. And then I'll fill out, we can use this to fill out the rest of the 6 steps. So the t statistic is minus 1.31. And the p-value is given right here, 0.1113, just rounding to 4 decimal places. So here's my p-value. And that's my alpha value. And so the p-value is actually greater than the alpha value, which leads us to the decision that we do not reject, because we do not reject. We only reject when the p-value is less than the alpha value. So we do not reject H naught. And finally, the conclusion. At the 1% significance level, the data does not provide evidence that, and here we're going to state the alternative hypothesis, that the mean wait time is less than 84.3 seconds, that the population mean wait time is less than 84.3 seconds. All right. So that's how we complete investigation 1. Please go ahead and complete investigation 1 on your own, following along with what I did. And then we have investigation 2, which you're also required to complete for this assignment. And it's about calibrating a pH meter. So yeah, it's pretty much a morph of what we just did. So give it a try. Let me know if you have any questions. All right, I'll see you in class or in the next video.